Alright, welcome to the playlist on limits and continuity. So in this video we're going to be talking about a very important concept, and that is the concept of a limit. Now this is something that you always need to learn after you know some basics about functions, and essentially limits are things that tell you the value of a function as you change the value of one of the variables. So essentially we express a limit as follows. So for example, let's say we want to find the value of the function y of x as x approaches a certain value, like x equals 0. Then what's going to happen with this is telling you that if you plug x equals to 0, what would be the value of the function? In this case, the function is just a straight line. So all you need to do is you plug in x equals 0, so that means that the value would be 0. Now that seems a bit too obvious, but there are a lot of functions that have very interesting properties, and it might not be so obvious every single time as to what the limit of the function is. And one of the reasons we need to study limits is because they are the foundation of a lot of other topics in calculus, in particular derivatives, integrals, and sometimes even summation and series. So limits crop up in quite a lot of different places, so they're one of the fundamental tools of mathematics. Now, if I were to tell you what is the limit of this function as x approaches something like 3, then all you would need to do is you would need to write limit as x approaches 3 of the function y of x, and then you would get the value of 3. Now, of course, this means that you can approach this value here by pretty much any side. So you can come from this side, for example, or you can approach it from the other side. And this is one of those functions in which it doesn't really matter which side you approach it from. It is still going to be the exact same value. And this is what we characterize as a continuous function. We say that a function is continuous at a point, at a specific point, if the limit at that point approaching from either side of the x-axis is exactly the same. So in this case, if we were to generalize this, we would say that y of x is continuous at a point. We should be specific because remember the limit is very specific to the point what you choose it on. So at a point, let's call it a, if the limit as x approaches a from the positive side, so that would mean from the right hand side of the x-axis, so it is moving to the left, of the function y of x is equal to the limit x approaches a from the negative side, so it will be from the left, of the function y of x. So we can already see that this is quite useful for making mathematical definitions. If for some reason we had a function that didn't obey this property, then it would have something called a discontinuity. So we're going to show that in a different video, but for now we're going to focus on how we evaluate limits. So apart from very regular limits, there are a lot of functions that possess limits that are very, very interesting. So one of the things that we can do is we can take a limit as x approaches something very large, like infinity. So as x goes to infinity, what do you think will happen? Well, if you plug in x equals infinity, then that's going to give you infinity. And that makes sense because if you look at the function, it keeps increasing. So if you go very, very far along the x-axis to the right, you're going to get positive infinity. And then if you go to the left, so that would be minus infinity, you'll get minus infinity. So it's very, very nice function. It has this sort of anti-symmetry about the y-axis. Very, very simple to deal with. Now, if we look at a function like this one, where you have 100 and then you have some sort of decay, exponential decay. So e is just a value like pi. It's 2.7 something, and it has infinite decimal places. Essentially, you have this. So the first value is going to be 100. So we could say things like the limit as x approaches 0 of this function y is going to be, well, e to the power of 0, that's going to become 1. So that's just going to be 100, which is not surprising because we know that the function is going to have that value. Now, the limit as x approaches infinity, so that one is quite interesting because it turns out that if you plug in infinity in here, Well, let's just rearrange this equation first. Let's write it down as 100 times e to the x. So I'm just bringing the power down, and I'm expressing the function in this form. Now, what do you think is going to be the limit of this function? Well, if we plug in x equals infinity here, this number is going to be e to the power of infinity. E is a number that is larger than 2. So that means that this will be something like 2.7 something to the power of infinity, which is going to be infinity. It's going to be a very large number. And then over here you have 100. So if you divide 100 by a very large number, you can imagine that this entire value is going to approach 0. And that makes sense because if you actually look at the shape of this function, you can tell that as you move along the x-axis towards infinity, this function will decay and it will reach 0 at some point. It's not going to cross the x-axis. It is never going to actually touch the x-axis, but if you let x go to infinity, then this function will get closer and closer to the value 0. And that's essentially what the limit means. Now, the next thing we need to talk about is, okay, so what happens to this function? This function keeps going, right? So it keeps going in this direction. So what do you think would happen if you take a limit as x goes to minus infinity? Then in that case, what we have is 100 over e to the x. Now, that means that we're going to have 100 e to the minus infinity. And this essentially means that we can bring the power up by making it positive. So that's 100 e to the power of infinity. And that's an extremely large number. So it turns out this is going to be infinity. Which is not surprising because we can see that if we move to the left, this function is going to continue to increase and it is going to reach a very large value eventually. So that's the basic idea behind limits. And in the next few videos, we're going to keep talking about some of these properties, how we can analyze functions with them, and what are some of the tools that can be useful for analyzing limits of functions.